Hi everyone, this is my SIT210 task 11.1 PCHD task. In this task, I will demonstrate my project. So, our project is a smart home panel. As you can see, we have used a touch screen and a Raspberry Pi 4. Here you can see we have used a webcam which recognizes people, and here we have used the LED and the DTS sensor. Along with this, we have used an Arduino Nano IoT33 device, which is located behind this black wall. The problem statement is not being able to identify visitors at your door when you are away. This situation can pose risk, like someone finding your keys and using facial recognition to enter your home. It could also enable a person you trust to unlock the door from a distance, even if their information isn't in the system. Our project have two objectives. Firstly, the automatic opening and closing of the door, and secondly, the control of LED brightness along with the display of temperature and humidity of the house. The software and hardware that we have used are listed below. For example, we have used Raspberry Pi 4, Arduino Nano, DHT11 sensor, touchscreen, LED, webcam. Along with this, we have also used jumper wire, which is quite common. The software which we have used is Firebase. For the face recognition, as you can see, first the webcam detects the person. If the person's data is stored in the database, it opens the door. Or if it is not stored in the database, it locks the door and send the email to the owner. Facial recognition. Yeah. Facial recognition is achieved using the OpenCV library designed for Python, which analyzes facial features. Additionally, Python 3 included a pre-installed library for SMTP, eliminating the need for a separate download. In its operation, facial recognition utilizes webcam to capture facial features and cross-references them with the database. Now, for the working of LED control and DTH11 sensor. Uh, for the working of DTH11 sensor, first the Arduino fetches the data which is sent by the sensor. Then it is sent to the Firebase. After the Firebase, after it is sent to the Firebase, it is displayed on the website, which is the GUI. But for the LED, uh, first the first we have the GUI, which has the slider for the brightness of the LED. It changes the values of LED brightness, sends it to the Firebase. The Firebase then sends the new data to the Arduino. Arduino then uh, sees the new data and execute the brightness on the LED. This is how the data sending work. For sending the data, we used a library called the Firebase Arduino Wi-Fi Nina to send information to Firebase. We create a user-friendly web page to show the data. The code connects to Wi-Fi using a provided network name and password. It gets humidity and temperature data from sensor. With Firebase, it sends this data to specific spot in Firebase's storage. It also gets the brightness level for an LED from Firebase and changes the LED's brightness accordingly. In our system, we have also used fault tolerance. Fault tolerance. Whenever the machine, which is our webcam system, fails to recognize the data, the owner can take matters in their own hands. We have a separate GUI for that, which allows the owner to open or close the door from any part of the world. In the further enhancement, we would like to enhance the fault tolerance. Whenever the email is failed to send due to some uh, network incapability, it will be queued. Email will be queued, and whenever the network is back, it will be automatically sent to the owner.
Hi, hi everyone.
This is the our project video, which is demonstrated by our group leader Aryan Sharma.
Hi everyone. This is our smart home panel. So this is the basic GUI for the controlling of the LED brightness and the real-time data of the humidity and temperature. So as you can see, the LED and the data sensor are placed over there just for the demonstration purpose. And whenever I'll turn on the slider, you'll see that the light will glow. So there's a bit delay, and we can change the brightness level too. The DHT sensor placed over there gives us the real-time data over this panel about the humidity and the temperature control. So currently the temperature is 27.7 degrees Celsius and humidity is 53.60, which is displayed through that temperature sensor. Now I'll basically show you how this main project works regarding the facial recognition. So there is a camera over there, and whenever I run the code, so it asks us that are you at home or not. So I'll just zoom it. Yeah. So it asks that are you at home or not. So whenever we press yes, so another piece of code runs. It just takes some time. As you can see, now the camera screen is so the camera display is displayed over here, and this is basically how the camera reads. And so what it does is basically it captures the image if an unknown person is there and display it over here that an unknown person is being at your doorstep, and captures the image of the unknown person and show it on the mail. So we'll provide you with a demo of this thing by showing a face of an unknown person. So now for the demo purpose, we'll show the picture which is not stored in the database. So it basically captures the image with unknown, and it will send me an email regarding that. So here is an email in the real time with the face of the person, and it is displayed as unknown. So this is the email. Now when we are out of the home and we want the remote access, we can just open the GUI which can be available on our phone by the name of entrance control, and we can control the servo motor which is being displayed here for the demo purpose. So whenever I'll press close door, so it is already in the closed door, so I'll press open door. So basically it rotates. So I'll first of all I'll close the door. So that's how it closes the door, and when I turn on open door, so basically turns in the reverse direction so that the gate can be opened easily.
So that's all for my demonstration. Thank you very much.